Just to be clear, the name creative u-substitution is not an official math way to describe this. It's just the way I chose to. There probably is an official term for it, but the only way I know to describe it to you is this is the kind of u-substitution we have to do when the inside, whatever's inside the radical or inside the parentheses, the power, the trig function, and the other piece either have the same degree or the part outside actually has a bigger degree. So if you think about most u-substitution, most of the time what will happen is whatever we choose for u is exactly 1 degree bigger than our outside part, because then we just take the derivative and it all works out. But there are times like this where we have to be a little more creative, but it's still u-substitution. So let's begin. This first one, the integral of x over the square root of 2x minus 1. So just like normal, you would think, all right, what should I choose for u? It would make the most sense to pick 2x minus 1 because that's the part inside the square root. Now I'll take the derivative. I get 2 dx. And if we just look at this part, we say, okay, I just have 1 dx, so I'll divide both sides by 2 and then end up here. If I go ahead and substitute in, I get 1/2 integral of square root of u du, but there's the problem. I've done nothing about that x on top. So I haven't been able to substitute it all the way into terms of u. So this is where we have to get creative, because we've taken care of the 2x minus 1, we've taken care of the dx, but we haven't taken care of the x on top. So this is where we have to be creative. We want that to be in terms of u. So we go back over here. And that shows us that u is equal to 2x minus 1. So what I can do is actually solve that equation for x by adding 1 to both sides and then dividing both sides by 2, or multiplying both sides by 1/2, whichever way you want to think about it. So I now know that x is equal to 1/2 u plus 1/2. So I can substitute x with 1/2 u plus 1/2. So this is where I had to get creative. Since I had 2 pieces with exactly x to the first in it, I chose u just like I normally would. U was 2x minus 1, but then I solved this equation for x, which I did down here, and I'm going to substitute that in for the x in the numerator. So now I have 1/2 u plus 1/2 in the numerator. So while that may not look very simple, it is now all in terms of u. So my next step is going to be to rewrite this. So the square root of u is the same thing as u to the 1/2, and I need to divide both pieces on top by that u to the 1/2. So again, I change the square root to an exponent of 1/2, and I'm dividing both parts of my numerator by u to the 1/2. So u to the first over u to the 1/2 gives me u to the 1/2, and u to the 1/2 on the bottom I can bring up to the top as u to the negative 1/2. Now I admit, it's taken some work to get here, but really once we're at this level, it's not all that complicated. One like that is one you've known how to do since you first started antiderivatives, likely, or soon after. So I'm just going to put the 1/2 out front here. I'll worry about it later. This 1/2. Here I'll add 1 to the exponent. That gives me 3/2. Divide by that. That's the same as multiplying by 2/3. So 2/3 times the 1/2. So that 1/2 comes from here, and the 2/3 is me dividing by 3/2. And then I will add 1 to the exponent over here, making it positive 1/2. Dividing by 1/2 will actually cancel out the 1/2 I already had. So these cancel out. Alright, so 2/3 times 1/2. The 2's cancel out. I have 1/3, but I do need to distribute this 1/2 inside, so I end up with 1/6. Tell you what, let me not jump any steps here. Let me write it out as completely as I can. So I'll leave the 1/2 out front. 2/3 times 1/2 is 1/3. Then the 1/2's cancel, so I just have u to the 1/2 plus c. Okay, you notice I did put parentheses around the plus c the first time. I didn't the second time. It honestly doesn't matter either way. They don't usually bother applying the coefficient to a c because 1/2 times a constant is still just a constant. So the point is we know there's a constant added. It really doesn't matter what we multiply it by. It's still just a constant being added to it. So then I can distribute the 1/2 through. 1/6 u to the 3/2 plus 1/2 u to the 1/2 plus c. My last step is what I would normally do with u substitution. I then need to plug in back the x values that equal u. So if we go back, way back to the beginning, u is equal to 2x minus 1. So I need to plug 2x minus 1 in for these u's. And that is our final answer. I know these take a long time. I know it may seem extremely hard right now, but I assure you, once you see a few, you'll see, even though it may not be super easy, the pattern is very similar each time. So if you'll just take it step by step, you'll see these are workable. They'll take some time, they take a long time, but they're not as difficult as they are long. So next example, x times the square root of 3x minus 2. So again, one thing that tells me I'm going to have to think about creative u sub is I see the exponents are the same in both pieces of this equation. So I'll start by choosing u just like I would before. U would be 3x minus 2. Du would be 3 dx. I am going to have to get rid of that 3 because I don't have a 3, so I'll have 1/3 du equals dx. So if you think about it this way, I've got this piece covered right over here. I've got this piece covered right here. So the part I still need to work through is the x out front. So I'll come over here and I'll take this equation and solve it for x. I'll add 2 to both sides, and then you can either divide by 3 or multiply by 1/3. So now I know that x is equal to 1/3 u plus 2/3. So I can write all this out. X is 1/3 u plus 2/3. This is now the square root of u. This is du. And I put a 1/3 out front. Sorry, my computer's getting a little slow on me. I'll give you a second to write and hope it catches up. Okay, good deal. That's a 1/3 out front there. Okay, now I need to rewrite the square root of u as u to the 1/2. And then distribute that through. So u to the 1/2 times u to the first. I add the exponents together. I get u to the 3/2. And then 2/3 times u to the 1/2. Alright. Now, it's finally time for the antiderivative. I'll leave the 1/3 out front. You could distribute it in if you wanted to. It really should work either way. But I'll add 1 to the exponent. Makes it 5/2. Dividing by that number, same as multiplying by 2/5. Add 1 to the exponent. Gives me 3/2. Dividing by that number, same as multiplying by 2/3. And of course our good friend, plus c. So So all sorts of coefficients we got to mess around with. But our last step is just to distribute all the coefficients through, and then we'll plug in what u actually equals in terms of x. So let's see, I get 1/3 times 1/3 is 1/9 times 2/5. I believe that's 2 over 45. Then 2/3 times 2/3 times the 1/3 out front gives me 4 over 27. Okay, and our last step is to go back up and say, what does u equal? U equaled 3x minus 2, so I need to plug that in for my u to get my final answer. Again, I know these take a long time, but I think you will see the pattern is very similar to how they solve each time. Okay, now what's different about this one from the first two is the powers are not the same each time, but in a more usual u-substitution problem, the power will be bigger inside. So it would normally be a power bigger inside the square root, but instead it's bigger outside the square root. But it's going to be very similar to what we did before. We're going to choose our u as 3 minus x. We'll take the derivative of that, it gets negative 1 dx. So we will need to bump the negative over, multiply both sides by negative 1. So we get negative du. So again, see the dx is covered right there. 3 minus x is covered. So it's the x squared we need to work out. So I'm going to solve this equation for x. Okay, so I'm actually going to add x over to this side and then subtract u from both sides, and that gives me x. So x is equal to 3 minus u. So when I substitute, I'll put parentheses 3 minus u squared. Don't forget to include the squared. In fact, if you wanted over here, you could just write x squared equals 3 minus u squared. If it makes more sense to do that over there for you, that's fine. But either way, don't forget the squared part. And then we get times the square root of u du. Okay, so we're all in terms of u. That's the goal. Now, two things I need to do. I need to actually FOIL this 3 minus u squared. Because remember, squared means times itself. So this is really 3 minus u times 3 minus u. So I'll FOIL that out, and I'll get 9 minus 6u plus u squared. And rewrite the square root of u as u to the 1/2. One thing I forgot. Please forgive me. I forgot about this negative out front. So I should have a negative out in front of all this. Now I need to distribute the u to the 1/2. So I get 9u to the 1/2 minus 6u to the 3/2, because I'm doing 1 plus the 1/2. And then u to the 5/2, because I'm doing 2 plus 1/2. Then I add 1 to the exponent. Give me just a moment, we'll let the computer catch up with what's going on. Okay, add 1 to the exponent. Divide by that number, same as multiplying by 2/3. Add 1 to the exponent. Divide by that number, same as multiplying by 2/5. Add 1 to the exponent. Divide by that number. With the negative and the c, it's the same issue. Having the negative out front is really just multiplying by -1, so that doesn't change the fact that that constant is a constant, so you don't have to put a negative with that. Mathematically, it's not wrong if you change it to negative c, it just normally isn't done that way. They just pretty much always leave it as plus c. So now we distribute or work out all our coefficients, and I'll go and distribute the negative through. So 9 times 2/3 is 6, and I apply the negative. 6 times 2/5 is 12/5, and I have two negatives here, so that'll be a positive. And then minus 2/7 u to the 7/2, because I'm applying the negative out in front of the parentheses. There we go. Don't forget that u. And our final step is then to plug 3 minus x back in for u. So that is the creative u-substitution. Might be a euphemism, makes it sound like a positive, happy thing when I say it's creative u-substitution, but there it is. And if you feel lost, I'd recommend you watch this again, because I really think once you see it, you'll see the pattern really does develop, and while it is long, it's not as complicated or difficult as it may appear. Good luck.